Respected sir and dear friends, I am going to give a presentation on paper entitled Forecasting Monthly Inflow with Extreme Seasonal Variation Using the Hybrid Sarima ANN Model, published by Hamid and Hossein in 2016. In this paper, they use the time series model for the prediction of inflow discharge in the dam and reservoir, and they use the linear seasonal autoregressive moving average Sarima model and combined with that non-linear artificial neural network model to predict the inflow accurately. And they compare the result from this with the individual Sarima and ANN model, and they find that hybrid model is more accurate than the individual model. Now the data is collected for 30-year the monthly inflow data from October 1980 to September 2011. The data were obtained from the Pearselman hydrometric station for the latitude and longitude shown in that slide. The Hurst coefficient can be calculated from the equation 1. That value should be greater than if you are going to use that. The monthly discharge measured in the dam reservoir experience intense seasonal fluctuation. The omega equal to 2 pi k. This is the frequency, and Ik is the spectral density. Ik is the amount of variance per frequency interval that can be facilitate the detection of periodical terms in noise time series by splitting the variance into the under stable periodicities. Alpha k and beta k are the Fourier series coefficient from the previous equation, and PM criteria show the severe change in the monthly inflow data. That PM can be calculated from the equation 6. If the value of PM is high, that means the peak value difference in the peak value and other data is high, and from the figure we can see that fluctuation is very high. If we see the relation between discharge and month, we can see the large fluctuation in that figure, and for the omega equal to 0.52, the value of Ik is large. And if we see the other figure, that cumulative frequency percentile, 80% of the data is lie below the discharge, 2.32, and other data lie beyond that. So the PM value obtained in this study is 10.5. We have to check the time series data, it is stationary or non-stationary. So trend and periodical component should be checked for the stationary or non-stationary data. If trend and periodical component are present, that means that time series is non-stationary, and we have to first convert into the stationary. And from the figure 2 spectral figure, we can also see that the periodical component omega equal to 12 is there. So periodical component is present and no trend has been seen from this figure. And ACF is endless and has the period with the mean 0, and PACF changes its sign immediately after the first leg, and its value are significantly high in the first two leg shown in that next figure, and therefore the only seasonal differentiation can make the model stationary. For the trend, man candle test can be used, that is shown in figure equation 7, 8 and 9. So to check the trend, we can use this equation, and if the data is satisfy the equation 10, then we can say that there is no trend and we can use the data. The Jark and Bera test confirm the data normalization as given in equation 11, where JB is the test statistics and SK is sample skewness, KU is kurtosis, N is the number of data. So after removing the trend and periodical component, the Sarima model can be used, where capital P and capital Q are the order of seasonal autoregressive and moving average parameter. Small p and small q are the order of non-seasonal autoregressive and moving average. In figure 3, the PACF and ACF can be shown, which I have already discussed in previous slide. The t-test, a coefficient significant test also applied, where tau is the t-test statistics, PR is represent the estimated parameter. The significance level is considered as 5% if the probability of tau in the t distribution is lower than 5%. the desired parameter will be significant. The box pH test used to diagnose the Sarima residuals linear relationship independently from the equation 14. And now ANN model. The ANN model have the three input layer, which is three layers, which is input layer, output layer, and hidden layer. So each layer has the neuron, and that transfer the result to the next layer, and using the transfer function. Now between these the relationship between input and output of one hidden layer expression is shown in 15. The hybrid model is the combination of linear and non-linear model, where Sarima is the linear model, and the input combination of Sarima model residual were used for the ANN model, which is the non-linear model. So from figure 4 we can see that the ANN and Sarima model used as a hybrid model total. So these model are used for the prediction of discharge. These are some statistical tools were used to check the model whether the model is good or not. So the MS and AIC criteria for Sarima 102 and 011 model is lower, and the value of box pH test is for this model is shown in table 1. The 14 input were considered as the input of ANN model. The residual of Sarima model is non-linear, so that residual was considered input for the ANN model, and ANN 9 model yield the best result among all the ANN. So these 9 and Sarima 102 and 011 were combined and made this hybrid model, and it is produced the best prediction result in the testing period. And the testing result can be also seen in the table, where the Sarima 102 and 011 with ANN giving the best result, with we can see the R square MAR which is low, and it is showing the good result. And the ACF and PACF from figure 5, we can see that this is the data after the seasonal differencing, and it is converging. So it has no seasonality, it has no trend and periodical term. The result can be seen in figure 6, where the observed data and predicted data from Sarima, ANN and hybrid model are plotted together, and it can be seen from the figure that the hybrid data is exactly lying on the observed data, and it is predicting more accurately than ANN and Sarima model. So we can say that the hybrid model is capable of more accurate result than the Sarima and ANN model. The coefficient of determination R square is shown in figure 7 for the different model, hybrid, Sarima and ANN. In this figure we can say that the hybrid model R square for training as well as testing period is more than the Sarima and individual ANN. The MARE and RMSE changes during the prediction period is shown in figure 8. Here we can see that for the short term the hybrid model is not that much good because of extreme seasonal changes. It is not showing good result. But if you see the RMSE value, it is much less than the individual Sarima and ANN model. So for long term we can use the hybrid model, and it is giving the good result than both the model. So the conclusion of the study was that the time series model can be used to predict the inflow of the reservoir, and in this study the non-linear and linear both model were combined, in which the Sarima model is the linear model and ANN model is non-linear model, and both were combined to form the hybrid model, and the hybrid model was giving the good result than both the individual model, and that model can be used to predict the discharge for the dam and reservoir, and that will help to manage the management for the purpose of irrigation and water management, and where we have to distribute the model. So accordingly we can use this type of model to predict the discharge, and it can be used for the various management in water resources.